Friends, thank you for being here today. What if I told you that the entire artificial intelligence revolution, worth over $7 trillion in market capitalization and representing humanity's next evolutionary leap, depends entirely on a single factory located on an island that China considers part of its territory and could invade at any moment? And what if I told you that this factory, operated by a Taiwanese company that most people have never heard of, possesses more control over the future of human civilization than every government, every military, and every corporation on Earth combined? Most people believe that artificial intelligence represents technological progress driven by American innovation, American companies, and American computational power. They assume that ChatGPT, autonomous vehicles, and advanced AI systems are products of American technological supremacy and American industrial capacity. They do not recognize what I recognize: the complete subordination of the global AI revolution to a single manufacturing facility that could be destroyed by a natural disaster, captured by a hostile military, or shut down by geopolitical tensions that are entirely beyond American control. This is not technology policy. This is civilizational vulnerability. The mathematical reality that humanity's artificial intelligence future depends entirely on the continued operation of one factory that produces the chips that make AI possible, and that factory is located in the most geopolitically unstable region on Earth. Taiwan's semiconductor manufacturing company, known as TSMC, operates the most advanced semiconductor fabrication facility in human history, located in Hsinchu, Taiwan, approximately 180 kilometers from mainland China. This facility represents the culmination of decades of technological development and billions of dollars in research investment, creating manufacturing capabilities that no other company or country has been able to replicate. TSMC's advanced fabrication processes, particularly their 4 nanometer and 3 nanometer technologies, are essential for producing the most sophisticated artificial intelligence chips ever designed. 100% of NVIDIA's H100 artificial intelligence processors, the most powerful AI chips available to commercial customers, are manufactured exclusively at TSMC's Taiwan facilities. These chips are not simply computer components that can be sourced from multiple suppliers or produced using alternative manufacturing processes. They represent the cutting edge of human technological capability, requiring manufacturing precision that approaches the atomic level in production processes that only TSMC has successfully mastered. The H100 chip contains over 80 billion transistors packed into a space smaller than a credit card, with each transistor measuring just 4 nanometers across. To put this in perspective, these transistors are approximately 25,000 times smaller than the width of a human hair and represent manufacturing precision that is measured in terms of individual atomic layers. The technical complexity required to produce these chips is so extraordinary that recreating TSMC's manufacturing capabilities would require years of research, billions of dollars in investment, and technological breakthroughs that may not be achievable by alternative manufacturers. NVIDIA's complete dependence on TSMC for H100 production means that every major artificial intelligence system currently operating or under development depends entirely on the continued operation of TSMC's Taiwan facilities. OpenAI's ChatGPT requires over 10,000 H100 chips to operate effectively, representing approximately $250 million worth of silicon that exists only because TSMC's Taiwan factory continues to operate without interruption. Google's artificial intelligence research, Microsoft's AI integration across all products, Meta's AI development programs, and Amazon's machine learning services all depend on access to H100 chips that can only be produced at TSMC's facilities. These companies have invested hundreds of billions of dollars in AI development, but their technological capabilities are entirely dependent on a manufacturing facility controlled by a Taiwanese company operating under the constant threat of Chinese military action. The scale of this dependency becomes apparent when examining the broader artificial intelligence industry and the computing power requirements of modern AI systems that have grown exponentially as researchers push the boundaries of what artificial intelligence can achieve. Training advanced AI models requires massive arrays of specialized processors working together for months at a time, consuming electricity equivalent to small cities and generating computational capabilities that were considered impossible just a decade ago but now represent the minimum requirements for competitive AI research and development. GPT-4, the AI model that powers ChatGPT and represents one of the most significant technological achievements in human history, required approximately 25 this versus 0 H100 equivalent chips during its training phase, representing computing power worth over 600 million, and consuming electricity equivalent to a medium-sized American city for 6 months. This enormous computational requirement is not an anomaly, but rather represents the new baseline for advanced AI development, as researchers attempt to create systems with human-level and superhuman capabilities. Every interaction with ChatGPT, every AI-generated image created by systems like DALL-E or Midjourney, And every machine learning prediction that powers modern search engines, recommendation systems, and autonomous vehicles depends on processors that exist only because TSMC's Taiwan factory successfully manufactures the most complex devices ever created by human technology. The artificial intelligence services that billions of people use daily are enabled by silicon that comes from a single fabrication facility located in one of the world's most geopolitically unstable regions. Google's revolutionary AI systems, including Bard, their search algorithm improvements, and their autonomous vehicle technology, all depend on access to H100 chips and similar processors that can only be produced using TSMC as advanced manufacturing processes. Google has invested over $100 billion in AI research and development, but these investments are worthless without access to the specialized silicon that converts algorithmic innovations into practical computational capabilities. Microsoft's integration of AI across all products, including Windows, Office, Azure Cloud Services, and their partnership with OpenAI represents a multi-billion-dollar bet on artificial intelligence that depends entirely on continued access to TSMC manufactured processors. The company's entire strategic direction and future revenue projections are based on AI capabilities that could disappear overnight if TSMC's Taiwan facilities were disrupted by geopolitical events or natural disasters. Meta, its massive investments in AI research, their development of advanced recommendation algorithms that determine what billions of users see on Facebook and Instagram, and their ambitious metaverse projects all require continuous access to the most advanced processors available, which means continued dependence on TSMC's manufacturing capabilities and Taiwan's political stability. Amazon's machine learning services that power everything from Alexa voice recognition to warehouse automation systems represent tens of billions of dollars in infrastructure investments that would become obsolete if advanced AI chip production were disrupted. The company's competitive advantage in cloud computing, logistics, and consumer services increasingly depends on AI capabilities that require processors manufactured exclusively in Taiwan. The mathematical reality of AI chip dependency reveals the extent to which the global technology industry has become vulnerable to single point of failure risks that could eliminate decades of technological progress overnight. TSMC produces approximately 90% of the world's most advanced semiconductors, including virtually all processors suitable for artificial intelligence applications. No alternative manufacturer possesses the technological capabilities needed to produce comparable chips, and developing such capabilities would require technological advances that may not be achievable within the current generation of manufacturing equipment. Intel, Samsung, and other semiconductor manufacturers operate advanced fabrication facilities, but none have successfully mastered the 4 nanometer and 3 nanometer processes essential for state-of-the-art AI chip production. Intel's most advanced manufacturing process remains stuck at 7 nanometers, while Samsung's 3 nanometer process has suffered from yield problems and quality control issues that make it unsuitable for artificial intelligence applications. The technological gap between TSMC and alternative manufacturers continues to widen as TSMC invests over $40 billion annually in research and development while maintaining exclusive partnerships with equipment manufacturers who provide the specialized tools needed for advanced chip production. Companies seeking to challenge TSMC's technological leadership face not only massive capital requirements, but also access to manufacturing equipment that may not be available to competitors due to exclusive supplier relationships. The geopolitical implications of global AI dependence on Taiwan-based manufacturing have created strategic vulnerabilities that extend far beyond commercial technology markets to encompass national security, military capabilities, and economic competitiveness for every major power on Earth. China's stated intention to reunify Taiwan with mainland China creates an existential threat to global AI development that could affect every aspect of modern technological civilization. Chinese military exercises around Taiwan regularly demonstrate China's capability to blockade the island and disrupt shipping routes that carry finished semiconductors to global markets. A Chinese naval blockade of Taiwan would immediately halt the export of AI chips to American companies, European research institutions, and technology firms throughout the world, creating shortages that could not be resolved through alternative suppliers or emergency production measures. A direct Chinese invasion of Taiwan, which Chinese leaders have repeatedly threatened, and American intelligence agencies consider increasingly likely, would create immediate disruption of TSMC's manufacturing operations and potentially result in the destruction of fabrication facilities that represent the pinnacle of human technological achievement. The loss of TSMC's production capabilities would set back global AI development by decades and eliminate the technological foundation that supports virtually all advanced artificial intelligence research. The strategic importance of Taiwan's semiconductor manufacturing has transformed a regional territorial dispute into a global conflict that could affect the technological capabilities of every nation on Earth. American military planners, European policymakers, and technology industry leaders recognize that Taiwan's semiconductor industry has become as strategically critical as oil reserves, nuclear capabilities, or control of major shipping routes. The Biden administration's export controls on semiconductor technology, designed to limit China's access to advanced AI chips, have inadvertently increased American dependence on TSMC's Taiwan facilities by reducing alternative supply sources and concentrating advanced chip production in a geographically vulnerable location. American technology companies that previously had limited options for AI chip sourcing now have essentially no alternatives to TSMC for the most advanced processors. NVIDIA's market capitalization, which exceeded $2 trillion at its peak, represents investor confidence in the company's ability to maintain technological leadership in AI chip design. However, this market value is entirely dependent on TSMC's continued willingness and ability to manufacture NVIDIA's designs using processes that no other company can replicate. Jensen Huang, NVIDIA's CEO, exercises no control over the manufacturing facilities that produce his company's most important products and generate the majority of its revenue. The dependency relationship between NVIDIA and TSMC has created a situation where the world's most valuable technology company is essentially a subcontractor, whose business model depends entirely on access to manufacturing capabilities controlled by a foreign company operating in a geopolitically unstable region. NVIDIA designs chips but cannot manufacture them. TSMC manufactures chips but lacks the design capabilities that create market value. This symbiotic relationship has created mutual dependency that benefits both companies, but also creates systemic risks that neither can address independently. The financial markets have begun to recognize the concentration risk created by AI industry dependence on TSMC's Taiwan facilities. Technology stock valuations increasingly reflect not only the commercial prospects of individual companies, but also geopolitical risk assessments related to Taiwan's security and TSMC's operational continuity. Market. Analysts monitor Chinese military exercises around Taiwan as closely as they follow earnings reports and product announcements. The insurance industry has struggled to develop coverage for technology companies whose operations depend on continued access to TSMC's manufacturing capabilities. Traditional business interruption insurance policies are inadequate for risks that could affect an entire industry simultaneously and for extended periods. The scale of potential losses from TSMC production disruption exceeds the capacity of global insurance markets and could not be fully covered through conventional risk management approaches. Supply chain managers at technology companies have attempted to develop alternative sourcing strategies and emergency stockpiling procedures, but the technical complexity and cost of AI chips make such approaches largely ineffective. Individual H100 chips cost approximately $25,000 each, making large-scale inventory stockpiling prohibitively expensive for most companies. More importantly, the rapid pace of AI chip development means that stockpiled processors quickly become obsolete as newer, more powerful designs become available. The limited shelf life of cutting-edge semiconductor technology creates additional vulnerabilities because companies cannot simply stockpile current-generation chips to protect against future supply disruptions. AI research progresses so rapidly that chips more than 12 to 18 months old become inadequate for state-of-the-art applications, forcing companies to maintain continuous access to the most recent TSMC production output. The natural disaster risks facing Taiwan add another dimension to global AI vulnerability that extends beyond geopolitical threats to encompass environmental hazards that could disrupt TSMC's operations without any hostile action. Taiwan sits on the Pacific Ring of Fire and regularly experiences earthquakes, typhoons, and other natural phenomena that could damage semiconductor manufacturing facilities or disrupt the supply chains that support chip production. Semiconductor fabrication facilities are extraordinarily sensitive to environmental conditions and require constant temperature control, vibration isolation, and contamination prevention to maintain the precision necessary for advanced chip production. Even minor earthquakes or power outages can disrupt manufacturing processes and require extensive cleanup and recalibration procedures that could halt production for weeks or months. The 2011 tsunami that devastated Japan's coastline provided a preview of how natural disasters can disrupt global technology supply chains. Japanese semiconductor facilities that suffered earthquake damage created immediate shortages of electronic components that affected automotive production, consumer electronics manufacturing, and industrial systems worldwide. A comparable disaster affecting Taiwan's semiconductor industry would create disruptions of much greater magnitude and duration. Taiwan's vulnerability to typhoons during the summer and fall seasons creates predictable periods when TSMC's operations face increased risk from severe weather events that could damage facilities, disrupt power supplies, or prevent workers from reaching fabrication plants. The precision required for advanced semiconductor manufacturing means that even Brief interruptions can require extensive recovery procedures that extend downtime far beyond the duration of initial weather events. Climate change projections suggest that Taiwan will experience more severe weather events in coming decades, increasing the environmental risks facing the island's semiconductor industry. Rising sea levels, increased storm intensity, and changing precipitation patterns could affect the infrastructure systems that support chip manufacturing and create new vulnerabilities that did not exist when TSMC's facilities were originally designed and constructed. The water requirements for semiconductor manufacturing add another environmental vulnerability because chip production requires enormous quantities of ultra-pure water that must meet stringent quality standards. TSMC's Taiwan facilities consume approximately 156,000 tons of water daily, making them vulnerable to drought conditions that could force production cutbacks or quality compromises that affect chip yields. Taiwan experienced severe drought conditions in 2021 that forced TSMC to transport water by truck to maintain manufacturing operations and implement conservation measures that affected production schedules. Future drought conditions could create more severe constraints on chip production, particularly as TSMC expands its manufacturing capacity and water demand continues to increase. The electrical power requirements for advanced semiconductor manufacturing create additional infrastructure dependencies that could affect TSMC's operations during emergency conditions or infrastructure failures. Chip fabrication requires continuous, stable electrical power with precise voltage and frequency control to maintain the environmental conditions necessary for reliable production. Power outages or electrical grid instability can damage equipment, ruin chip batches, and require extended recovery procedures. Taiwan's electrical grid faces increasing stress from growing industrial demand, extreme weather events, and aging infrastructure that may not be adequate to support continued expansion of semiconductor manufacturing capacity. The island's limited size and geographic isolation make it difficult to develop redundant power generation and transmission systems that could maintain reliable electricity supply during emergency conditions. The skilled workforce required for advanced semiconductor manufacturing represents another critical dependency that could affect TSMC. As operations if geopolitical tensions or security concerns force evacuation of foreign technical personnel or disrupt the international recruitment programs that bring specialized expertise to Taiwan and its facilities. TSMC employs thousands of engineers, technicians, and skilled workers who possess specialized knowledge about advanced chip manufacturing processes that cannot be quickly replaced if political instability or security threats disrupt normal operations. Many key personnel are foreign nationals who could be evacuated by their home governments during crisis periods, creating immediate gaps in technical capability that could halt production. The international semiconductor equipment industry that supplies the specialized tools needed for chip manufacturing could also be affected by geopolitical tensions or export restrictions that limit access to critical components and maintenance services. TSMC's fabrication facilities depend on equipment from American, European, and Japanese suppliers who might face restrictions on providing products or services to Taiwan-based operations during international conflicts. The complexity of modern semiconductor manufacturing equipment requires continuous technical support, software updates, and specialized maintenance that cannot be performed by local personnel alone. Disruption of international technical support relationships could gradually degrade TSMC's manufacturing capabilities, even if facilities remain physically intact and operational. The global artificial intelligence industry has created a technological civilization that depends entirely on the continued operation of manufacturing facilities located in one of the world's most geopolitically volatile regions. This dependency represents a strategic vulnerability that affects not only commercial technology development, but also national security capabilities, economic competitiveness, and scientific research capacity for every country seeking to participate in the AI revolution. The mathematical certainty of this vulnerability cannot be disputed through policy statements or alternative development strategies. Advanced AI systems require TSMC chips. TSMC chips are manufactured exclusively in Taiwan. Taiwan faces existential threats from military action, natural disasters, and infrastructure failures that could eliminate global access to the semiconductors that make artificial intelligence possible. The transformation of semiconductor manufacturing from distributed industrial capability into concentrated technological dependency represents one of the most dangerous strategic developments of the modern era. The efficiency gains and technological advances achieved through manufacturing concentration have created single points of failure that could affect the entire trajectory of human technological development. Most people do not understand how completely their digital lives and economic futures depend on the continued operation of fabrication facilities located thousands of kilometers away on an island that most cannot locate on a map. The artificial intelligence systems that increasingly power search engines, social media, autonomous vehicles, and countless other applications exist only because TSMC's Taiwan factories continue to produce the chips that make AI possible. The NVIDIA apocalypse is not a theoretical risk or a distant possibility. It is a mathematical certainty that will occur when TSMC's Taiwan operations are disrupted by military action, natural disaster, or infrastructure failure. The only questions are when this disruption will occur and how long it will last. The artificial intelligence revolution that promised to transform human civilization has instead created dependencies that could eliminate technological progress for decades if the wrong factory stops producing chips. The age of artificial intelligence began in Taiwan and will end in Taiwan when the factories that make AI possible are destroyed, captured, or shut down. The future of human technological development depends entirely on the security of one island, the stability of one company, and the continued operation of fabrication facilities that represent the most advanced and most vulnerable technology infrastructure ever created. This is how technological revolutions create technological vulnerabilities. The chips that make artificial intelligence possible are produced in a place that artificial intelligence cannot protect. The most advanced technology in human history depends entirely on the most precarious geopolitical situation on Earth. Jensen Huang may design the future, but TSMC's Taiwan factories determine whether that future will exist. If discovering that the entire AI revolution hangs by a thread in Taiwan left you speechless, brace yourself for what's coming next. The single point of failure I just exposed is only the beginning of a technological house of cards that is about to collapse. Hit subscribe and smash that notification bell, because as the next video reveals a dependency so shocking that it makes NVIDIA's Taiwan problem look like a minor inconvenience. When you see how fragile the foundation of modern civilization really is, you'll understand why those who recognize these patterns first will be the only ones prepared for the reset that's coming. The dominoes are already falling. Don't get caught unprepared.